Chapter 7, we get to talk all about moles. We've got one more. So we talked a little bit about what a limiting reagent or a limiting reactant is. I think it's pretty straightforward, but you should be able to define it. A limiting reactant limits the amount of products that can be made. So it's the thing that runs out first. So in the car engine, the oxygen isn't able to get to the engine fast enough to burn all the fuel. The oxygen runs out first. It's the limiting reagent. So sometimes you'll have a question that says, this is burned in an excess of oxygen. That's just telling you that oxygen is not limited in that situation. It's whatever you're burning. That's the limiting reagent. Okay, so what is a mole? 1 mole is equal to 6.02 times 10 to the 23 atoms or molecules of that particular substance. So I think I've said this so many times, but a mole is just like a dozen. It's a number that is just scaling up. So if I have 1 egg and then a dozen eggs, I have 12 eggs, but it's a certain volume, right? If I have 1 bowling ball and then a dozen bowling balls, that's a lot bigger volume than the eggs, but it's still a dozen. Okay? In the same way, if I have 1 mole of hydrogen atoms, you know, they're going to take up a certain volume. They're pretty small. But if I have 1 mole of iron atoms, they're going to be huge. That's going to be a very large volume. But it's still 1 mole. Every substance has its own molar mass. Okay, so you look on the periodic table to figure out what the molar mass is. So for hydrogen, its atomic mass is 1.01 AMU, atomic mass units. This is hydrogen. Okay, this is the weight of 1 molecule of hydrogen. But if we scale that up, and of a dozen molecules, right, we're going to scale it up. Instead of a dozen, we're going to scale it up to 1 mole of hydrogen. That's going to be 1.01 grams. Okay. Now, if we do that for iron, what's the molecular weight of iron? You look on the periodic table. Where is iron? And by the way, iron is Fe because the Latin word for iron is ferrum. Can't find it. Where is iron? When I'm on the spot, I can never find it quickly. Thank you. 55.85 AMU is 1 molecule of iron. 55.85 grams is 1 mole of iron. Okay? This is unique to iron. This is unique to hydrogen. 55.85 grams of hydrogen is not 1 mole of hydrogen. This is only true for iron. So then we can do the same for molecules. For water, to find its molecular mass, we could find the weight of 1 molecule of water. So we know hydrogen is 1.01, and we have 2 hydrogens. So we have 2 times 1.01 plus the weight of oxygen, which is 16 even. So that's 2.02 plus 16, 18.02 AMU is the weight of 1 molecule of water. Now, if we want moles, 18.02 grams is the weight of 1 mole of water. And again, this is just unique to water. This is the molar mass of water. So then we can go the other way. If I have, let's say I have 95 grams of let's just say methane. How many moles of methane is that? And how many molecules? Let's just go ahead. So 95 grams. Well, first we need to say, what's the molar mass of methane? Well, carbon is 12.01, right? On the periodic table. Hydrogen is 1.01, and we've got 4 of them. So we'll do 4 times 1.01. So that's 4.04 plus 12.01, so that's 16.05. Is that right? It's the molar mass of methane. So we know that 16.05 grams is 1 mole of methane. So now we can go with what we have, and we'll do our trusty conversion technique that works for everything. We've got 95 grams, so we write what we have, put it over 1, make a times and a fraction. Now we have our conversion relationship. We know 16.05 grams, and I'm writing it on the bottom so we can cancel out grams, is equal to 1 mole of methane. So now I can cancel out grams, and now I see 95 times 1 times this, and now I see I have to divide. So I don't have a calculator, but the answer would be, I guess I'll have to use this as a calculator. I usually use my phone, which is recording right now. So 95 divided by 16.05. So we've got 5 I only had 2 significant figures here, so I need to express my answer in 2 significant figures. 5.9 moles of methane. Now, how many molecules of methane do I have? So I write down what I have. Put it over 1, make a times and a fraction. Now I know that in 1 mole, there are 6.02 times 10 to the 23 molecules. So I can cancel out my moles. My remaining unit is molecules. So now I can do 5.9 times 6.02. 5.9 times 6.02 is 35.518, but I only have 2 significant figures, so I need to round that to 36 times 10 to the 23. Now I can move my decimal over 1 more, and this is going to be 3.6 times 10 to the 24 molecules. Okay? So that's pretty elementary, right? We've got several questions over that. We did the experiment with the anhydrous versus hydrated copper sulfate or whatever it was. I can't remember exactly. There will be questions about that, figuring out how many moles of water something can absorb. And then we can expand that to chemical equations. So let's burn something. Give me a hydrocarbon. Pentane. Pentane's, it's H10, right? 3, 8, I know I should be able to use 3, 6. It's 12, is that right? I know I figured it out. 2, 4, 6, wait, 1, 2, 3, 4, 5, yeah. 2, 4, 6, plus 3, 9, 12, okay. So let's burn pentane. So whenever we have a combustion reaction, it's with oxygen, and that makes carbon dioxide and water. So let's balance this equation. Got 5, let's do 5. So that's 5 carbons. There's 12 hydrogens here, so we need to do this to make 12. And now we've got oxygen. Here is 2. Here we've got 10 oxygens. 5 times 2 is 10. Plus 6 oxygens is 16. So we need to put an 8 here to make 16 oxygens. Okay, so now this is balanced. Now, let's say we have, how many grams of pentane did we start with? Let's just say 50. 50 grams of pentane. And we want to know how many grams of carbon dioxide are produced. Let's figure out the molar mass of pentane. So we've got 5 carbons, which are 12.01, plus 12 hydrogens,